Hello, this is Unit 11, Lesson 1 about isometric drawings in nets. Just making this video, I know we talked about it in class, so it's not any real big deal, but we'll get that taken care of too, so just so you have a complete record. Okay, let's take a look at what we got. Okay, definitions and such. What they've got here is they're showing you an isometric drawing of a three-dimensional object. You've seen this before. Notice that they have the front labeled and the left and right will be to your left and right whenever you go to draw the different views. Okay, this is called an isometric view because you're looking at it from an oblique angle and you're above it at the same time. The other things that we're going to generate from this are called orthogonal views, and they're either from the top, front, left, or right side. Okay, let's see how we do that. Using the isometric drawing, draw the indicated orthogonal views. And once again, orthogonal just means that you get on that side of the object and look straight at it. Okay, so there's our isometric view. So we're going to look at the front view. The front view would look something like this. Okay, the top view is going to look a little kind of strange because you're going to have three going across, two with a gap on the left side and two with a gap on the right side. So that's what this would look like, something like this. Okay, next we're looking for the left side view, so that we have to imagine ourselves getting on the left side of this object, and once we get there then we can look straight into it and we'll get something that looks like this. And from the right side, if you can notice what you're saying, you'd be on the right side of the object. So looking straight in, you're going to get something that's actually a reverse of the left side view in this case. Won't always be true, but it is in this case. Okay, just turn the camera off so you can see the whole thing. So go ahead and get what you need, and I'll give you a couple of seconds and we'll move on. Alright, let's look at examples 1 and 2. A net is a two-dimensional representation of a three-dimensional object. Now, the three-dimensional object that they're giving us in this case is this right here. So it turns out to be a cube. Okay, it will look something like this. Okay, there's more than one possible way that you can draw this, so if you've learned different ways to draw this, you can draw it a different way. Just make sure that it does fold up into the cube. Okay, one of the places that they use this quite frequently is in box manufacturing, because if you have boxes and they come into you, they'll come in flat on a pallet, and they look something like this net, and because they're pre-creased so that you can go ahead and fold it into whatever shape you need it to be. Another place they use this kind of thing is with envelopes, because envelopes come out of a single sheet of paper. They cut them and then they fold them to fit a certain pattern. Okay, example 2 wants to know how many faces and vertices does the three-dimensional object have. Okay, to look at the faces, you just count the faces on the net and you can see there are 6 faces there. To get the vertices, look at the ones on the top. So there's 4 up here, there's none in the middle, and there's 4 on the bottom. So 4 plus 4 is 8. Okay, a lot of times once they have you do this, they'll ask you how many edges this thing has also. So if you're going to count them, you got 4 on the top, you got 4 around the middle, and 4 at the bottom. So this gives you a total of 12. Another way that you can arrive at it is if you take the faces and add the vertices to it. The 6 plus 8 is 14. If you subtract 2, and the 2 is always what you subtract from it, that will give you 12 also. Okay, example 3. They want you to draw a three-dimensional object that is the result of folding this net along the dotted lines. So here's the net we have. As you can see, what you're going to end up with is a triangular pyramid, sometimes called a tetrahedron. Tetra is the Greek prefix for 4, and hedron is just a name for all these three-dimensional objects in general. Okay, just like polygon is for flat objects, polyhedra are what they use for three-dimensional objects. Okay, so if you fold it up the way they ask you to after you cut it out, then you should have something that would look like this. Okay, this wraps up Unit 11, Lesson 1. So remember, if you have any questions, write them down now, bring them to the class, and put them on the parking lot, and we'll be glad to answer those, or you ask them directly, whichever way suits you. We'll be glad to cover those before we do any kind of work with it. Thank you very much. Goodbye.